All right, listen in carefully and do pause the video if you need more time on it, but I'm going to go pretty fast on these so you can get a quick look at it. So the first thing you have is find the sum of the measures of the interior angles. You know the formula is n minus 2 times 180. So it's 45 minus 2 times 180. That gives you 7740b. Number 2 is g. Find the value of x. These are 4 angles in a quadrilateral. You have to add them all up and set them equal to 360. Because of n minus 2 times 180 equals 360. There's 4 sides. So I solve that, you get x equals 66. That's g. Number 3, the sum of the measures of the exterior angles, which is always 360. Remember, interior angles is n minus 2 times 180, so it can get pretty big. Exterior is always 360. That's d in number 3. 4, which of the following is a property of a parallelogram? Feel free to consult your chart, your flow chart. But the only one that works, each pair of opposite sides is congruent. The other, only one pair of opposite side angles is congruent. Does not make it a parallelogram. Then you're talking about a different shape. A pair of opposite angles is supplementary. There are 4 right angles. Those are things that are very specific that are not necessarily part of a parallelogram. 5, parallelogram ABCD angle 1 here. That's because it's a parallelogram. This 36 alternate interior angle is congruent to angle 1, so it is 36 in number 5. So that would be C. Then a 6 down here, parallelogram with diagonals intersecting at E. What we know about a parallelogram is the diagonals bisect each other. So if we see AE is 3x plus 12, then EC, which is 27, would be the same length. So you set those two equal. So you can see that down here. These guys are equal. Solve that for x equals 5. Thankfully, that's all it's asking for. So you see that x is, in fact, 5, which is F. Next piece. Number 7 is asking for the values of x and y, and it is a parallelogram. So what we have is that opposite angles are congruent altogether, but more specifically, it's still, because it's a parallelogram, this little angle up here it's pointing to and the alternate interior angle here down below, those are congruent. So I set those equal by alternate interior angles theorem. And then opposite angles, as I was saying before, those are congruent. So I set the two y expressions equal to each other as well. Solve each. 13 for x, 24 for y. The one thing that might hang you up, I want you to be careful and look at, when I get to 12, x equals 1/2 y. To get rid of 1/2, you have to remember that you multiply both sides by 2, which is the reciprocal of 1/2, and that cancels that out to be 1. So you double each side. Or you can think of a half of some number y is equal to 12. Well, a half of 24 is what works. But do remember, if you have a half times a variable, you multiply by 2 to get rid of it. That's where I get the 24 from. Then number 8, find the value of x, so it's a quadrilateral. That's a parallelogram. Again, opposite angles would be congruent. Kind of redundant. Solving for x, x equals 36. That's H. 9, we plot these vertices. So I'm going to carefully go to a graph here in a minute, and I'll show you exactly what I mean. Okay, so here's how you plot those points. The points are listed. A is 8, 2, B is 6, -4, C, -5, -4. Go find D, such that this is a parallelogram. So if you take a look, there's A, B, C, and then I want to make sure that in a parallelogram, what I get then for that point D is the same slope as I just marked out there in blue. So you get the same rise, which is 1 up 2, 3, 4, and over 2, or 4, 5, 6, I'm sorry, over 2. So what I want to do is mimic that same rise and run over on the left to get the same slope, so I have parallel opposing sides. So up 6 and over 2 again. That lands me at the point -3, 2, and that'll be our D. So that solves that problem. So -3, 2, which is B. And then 10, ABCD, rectangle, I have it listed down here. And AC is 5x plus 2, the whole diagonal. And BD, the other whole diagonal, I've written it off to the side, is x plus 22. Diagonals are congruent in a rectangle, so those get to be set equal. Solve for x as we always do. X equals 5. And then, you're thinking, do I need to plug that back in to answer the question? Not in this case. So you find that you get F5 is x. 11, which of the following is true for all rectangles? All the others up above are not true for all rectangles. So what we do know is that the consecutive sides are perpendicular. That's true for every rectangle. Next piece. I'm going to turn the page over, and what we're going to look at is ABCD as a rectangle. And those are points plotted in there. Find the coordinates of A. So same process. So let's take a look at 12 first. So if you take a peek, you just got to plot those points, A, B, C, or the B, C, and D that are given. And if you do that, you get them all in there, B, C, and D plot nicely, and then it says find the coordinate A, so you get a rectangle, and you just go straight up. Easy peasy, right? Now, let me back up. Now down below, what you're going to see here is number 14, or number 15. I wanted to jump to 15 since I'm already in a grid, so go look at 12. If you got that one plotted, point A is 10, 6. Will you go to 15 with me? The correct answer is A, negative 3, 1, and let me show you why. So 15, just like you normally do, you just want to plot the points. Got them all in there. Label them carefully. Just be careful. So we got A, and then the lower right B, and then C. And we're supposed to put D in there. Now, if I had to write this really carefully, if I had drawn this, I think my first instinct would have been to, just go down, let's see, 1, 2, 3, 4, over 2 to get A. So I have to do this, so I'm marking it there. So for getting D, I would just get down 4 and over 2. I put it on there, and there's D. Well, that'd be the wrong answer. And if I were writing this multiple choice, that would have been one of your answer choices, and it would have sucked in a few. But be careful, this asks for an isosceles trapezoid, not a parallelogram. The question wants an isosceles trapezoid. So I got to go out to the left, too, so that the sides on the left and right are the same. And it looks like a trapezoid. You notice that's only one set of parallel sides. So the point's negative 3, negative 1. That's number 15. So just be careful as you're doing that. So as like we were just saying, we just got J for number 12 and number 15 down there, negative 3, negative 1, which is, sorry, that's A. Just write the letter in there. Number 13, it takes a little bit more. Find in rhombus GHK angle 1. Now the things we know about a rhombus is that the diagonals bisect the opposite angles, and the opposite angles are congruent because that's anything in a parallelogram. So I've got 22 given, so I wrote in 22. The opposite side would have the same angles, 22 and 22 bisected. And to find angle 1, this is what I want you to notice. Angle 1 is inside a triangle that has, and you also know that the diagonals are perpendicular in a rhombus. So I really just marked this up with all the things I know about a rhombus. And that comes in handy, like the bisected angles and things like that. Same thing up top. But this is a 90, 22, and then some other angle. And we know in a triangle they add to 180. So what I have up above is that 90 plus 22 is 112 for the two given angles. And then if I subtract from 180, I can get that other missing angle, number 1, which is 68 degrees C. Number 14, it's parallelogram. Or, I'm sorry, diagonals of square, ABCD. And what we know about a square is diagonals are definitely congruent. And we know that the big diagonal is twice as big as, half of the diagonal. Diagonals are congruent and split. So what I've done over here to the side, if you look at this equation, I just know the 2x plus 6 that I've labeled AE really carefully. I know it takes 2 of those, so I added it twice. That's one way to tackle it, or you could do times 2. And that's equal to 6x minus 10, the other diagonal, the whole length diagonal. And then I'll solve that ever so carefully, as you see below. X equals 11, and that happens to be almost what the equations look at. This is a plug back in type. When x equals 11, well, you got to put it back in to any one of these you want to choose. I'm supposed to find AC, the length of a whole diagonal. You can put it into 2x plus 6 over here like I did, and then double, get 28, and then double it. Or you can put it into 6x minus 10, which would be 66 minus 10, and you get 56. Either one's just fine. Either way, the answer is H. And we already did 15, so we're on to number 16. And 16, isosceles trapezoid, that means the sides, non-parallel sides are congruent, and you also get congruent base angles. So whatever you have in the lower, those two corners, those are the same. And then the upper angles are also the same. But if I back up, it's also, because it's two sides that are parallel, you can do all that alternate interior angle thing. This is 36, the alternate interior is 36. And down below, I can do the same thing, 36, 36. And because the base angles, these are 44 and 36, I know these are 44 and 36. This is pretty cool. Now, the angle I'm going for down below is I just need to find out the measure of MNP. So I have to do a little bit of triangle calculation that's going in here. Oh, by the way, I meant to put this in here. These are not true. You can't have that. You can't just write them in as being the same. Sorry, that's supposed to be like, this is a bad assumption. You cannot do that. You can't just say they're the same, because you notice this angle is congruent to this one, but we don't know about these guys up here. You can't just add those together and make that work. So I meant to put that in blue. Sorry, that's not in there on the bottom here. But we do know 44 and 36, 44 and 36 here in the bases. But what we have to do is solve this thing, and I'll keep wiping out those other angles. I even think I wrote 44 in there. This triangle here is how I'm going to find it. So 44 and 36, find out what they add up to. And that's 80, and then you add the 36 next to it. Together they make 116. And if you take 180 minus 116, you get 64 left for that upper corner in that triangle. So it's 64. Sorry again for the mistyped piece there. I must have been going quick when I did this before. So that's G. And then 17. If you go down there, the length of the base of the trapezoid, 19, the midsegment, 16. And to find the missing other base, remember you do the sum of the two bases, which I got on top here, divided by 2, is equal to the midsegment. So this is what it starts as. But part of the solving process is you multiply both sides by 2. So what you see right now is me multiplying both sides by 2 here and by 2 here. And that means x plus 9 equals 36, or 32. And if you subtract 19 from both sides, you get x equals 13. And that is the length of x, or the top base. It's number 18. If I plot all those points, you just get rolling through this thing looking good. Plotted them all in there. Get those sides connected. Thinking, man, are those really parallel? I kind of goofed up the point too. Notice my negative 16, 1 over in the left corner over there. It didn't quite make it a negative 16. It looks like it's on 15. There, I'll be careful with that later. I'll show you what I mean. But what I want to go back and look at is that those, you got to find out if the slopes between those connected lines are the same. That's negative 16, 1. So if I make some nice slope lines there, that's rise over run, are the same. Are the rise and the run, are they the same in each case? So is this rise and this run the same as the other rise and the other run? If they are, it means we have same slopes going on. I'm sorry, well, the same slopes on these sides are their consistent slopes, and then I need to compare it to the other sides. Well, you can play around like that all you want. The biggest thing is opposite sides have to be parallel. If I look at this really carefully, and these guys, up and over, that's 4/10 and 4/10 for the slopes. Those are parallel. And then if I keep going ahead, the others, that's a nice, negative 4/10. And then on the other side here, I can do the same thing. I got a nice negative 4/10 slope on the other side. Nice parallelogram, so that's good. But then you can go further. It's not just a parallelogram. You can actually look at the diagonals. If you go across here, nice and perpendicular. They're perfectly horizontal, or perpendicular to each other, perfectly vertical, perfectly horizontal. We're talking rhombus here. This is parallelogram. The sides are the same length, same up and over for both of those. They're parallel. We got a lot of good things going here. Perpendicular, bisect, diagonals. Yeah, we're definitely talking rhombus here. So lots of characters. So we'll go with the old H rhombus for number 18. Hope that helps. Let's get on to the next one. Number 19, we have a kite. Cool thing about a kite, these opposite angles are congruent. So I'll show you how I come up with those 124s in there. I know that I've got 22 and 90 for two of my angles. That's 112. And so if I take that from 360, that leaves me 248 degrees left for these two angles, top and bottom, Q and S. And well, Q and S are equal. So I just split 248 in half, 124, get D for number 19. Number 20, if I graph this one, if I plot the points in 20, as you see here, we got A is 4, 2, and then we got B is 4, negative 1. So A, B, and then C as negative 2, negative 1, and D up here. It says what would you have to determine, what would you have to do to find out that's definitely a rectangle? Diagonals congruent. Remember, that's how they made the picture frame, a perfect picture frame that's a rectangle. That's how you fix a fence that's sagging. You have to have diagonals be congruent. So do find that, you got yourself a rectangle. That's it.